from the Department of Informatics. I'm Elena Simpel. I'm a professor there. So glad to see so many of you here, and there's quite a few of you also online. It's a great pleasure for me personally to welcome Denny Vrandečić, who at King's last year. He also has a King's email address if you want to contact him that way. Just a brief introduction. So, who here has heard about Wikipedia? Hands up. Okay, good, Wikipedia. So Denny's on a board of trustee of Wikipedia. Who here has heard about MediaWiki? Oh, very good. So Denny is one of the founders of I know that, of one of the extensions of MediaWiki that does wonderful things that he will maybe tell you about in this talk. Who here has heard of Google? Oh, good. And the Google Knowledge Graph? Also a bit less, but still. So Denny used to work as an ontologist, very cool name, for the Google Knowledge Graph. Who here has heard about Wikidata? Excellent. So he found it. And now he's head of special projects at the Wikimedia Foundation out of Germany, working on a project called Abstract Wikipedia. Which I'm sure he's going to tell you about. So Denny, really, really happy that you made it to London. I hope to see you times and times again soon to work with us and with students and colleagues on a range of projects. But until then, looking forward to your talk on knowledge in the age of AI.
So, thank you all here. Thank you for coming and to the talk. Also, thank you for the honor of talking at King's College. Really nice to have you here. As Elena mentioned in the introduction, I'm working for the Wikimedia Foundation, the NGO supporting the Wikimedia movement. We are the organization behind Wikipedia, the free encyclopedia that anyone can edit. Elena already asked who here knows Wikipedia, so I'm going to skip that part. But in fact, when I started talking about Wikipedia, this was a question which made sense to ask. Today, there's no really point to ask about it. Wikipedia's vision is a world where everyone can share in the sum of all knowledge. Let's stay for one moment with this phrase. Everyone can share in. It's a bit awkward, I was told by a native English speaker, but it's a bit intentionally awkward. It aims to capture the two sides of sharing at the same time. And I consider both of them to be really, really important. On the one side is the ability to access knowledge, to read the Wikipedia articles, to get to know this knowledge, which is what people usually see and associate Wikipedia with. But it's also about the ability to contribute to the sum of all knowledge. The ability to have your voice and your knowledge be shared with the world. To share in aims to capture both sides. The passive side, the access to knowledge, but also the active side, to contribute to the knowledge. Well, how are we doing with regards to that vision? Wikipedia today is available in more than 300 language editions and provides more than 60 million articles in those languages, about more than 25 million topics. That sounds pretty awesome. You can contribute in more than 300 languages. You have access to huge amounts of knowledge. But it is wrong to assume that there's one Wikipedia. In reality, there are more than 300 language editions, and they are mostly independent of each other. If you write an article in one language or change an article in another, there isn't much that automatically propagates the knowledge to other languages. This is also why the knowledge in Wikipedia is very unevenly distributed between languages. On the one side, we have English with more than 10% of all articles, almost 7 million articles. On the other side, for example, for Turkmen, the official language of Turkmenistan, spoken by more than 4 million speakers. We have only 7,000 articles, a difference in a factor of about 1,000. Beautiful articles, such as about Gladstone, the resident mouser of His Majesty's Treasury, are only available in 5 languages. We have a lot of languages that are missing those articles, but also many more important articles in that one. So really, regarding giving everyone access to the sum of all knowledge, we are still far away from achieving that goal. Is there something that can maybe help us with this task? Well, coming back to the title of our talk, there's this new big thing, right? AI, artificial intelligence. Artificial intelligence is a term that has been coined and popularized in 1956, the same famously during a summer workshop in Dartmouth. But 1956 was also the year that the term informatics has been introduced, which features in the name of the institute here. So both terms are now almost 70 years old and have done a lot of work in that time. Can you hear me well, by the way? Okay, perfect. But the term AI faced a form of curse, the so-called AI effect. The AI effect has been formulated by a number of people, such as John McCarthy, Pamela McCorduck, Larry Tesler. One formulation I like in particular is by Rodney Brooks, an MIT researcher whose claim to fame is the company iRobot that brought Roombas and thus robots into many households. Rodney Brooks said, every time we figure out a piece of AI, it stops being magical. And we say, oh, that's just computation. And this way, whenever there was a success in AI, it became just a normal part of informatics or computer science, and we stopped calling it AI. Until a few years ago, maybe most notably in 2022, and that's the year OpenAI released ChatGPT. Arguably the one product which popularized modern AI, most notably machine learning, deep learning, and large language models, and brought them to a very wide audience. I was so surprised when my brother, who is really a laggard on the technology adoption side, actually called me and asked me about ChatGPT in 2023. So how does this work? How does this AI stuff work? I'm obviously not going to go into detail about it, but here's just a rough intuition. In machine learning, the goal is to design an architecture that can run more or less arbitrary programs on some input to calculate a fitting output. Or put differently, you ask a question and get an answer. Just one moment, someone on Teams has their microphone open.
Yeah, my bad, Denny, John Davis, sorry.
Okay. Sorry? Ah, okay, nice to see you. I hear you. So, these systems are so-called artificial neural networks in many cases. They were inspired by how people thought neurons in animals work, in humans too, but really just inspired. Today we know that there are many different types of neurons, that there are neurotransmitters that make the whole thing change, the working in different ways. The natural neural networks are much more complicated than we thought. And the architecture of a brain is very different than most architectures of artificial neural networks today. There are quite a number of possible architectures for these models. Here are just a few examples. Early on came simple perceptrons introduced in the 1950s, simple flows of input through weighted neurons and functions to select an output. Whereas this could be deterministic, in many cases, a parameter called temperature gave some wiggle room on each step, making those systems somewhat probabilistic or stochastic. The 70s and 80s then saw the development of Hopfield networks, where the output of a neuron could feed back in a neuron of the same layer, and thus called recurrent neural networks. Then in the 90s, we saw bidirectional recurrent neural networks. They were added to the list of architectures. And the 2010s saw the introduction of the transformer, a system that could, in self-guided ways, use attention to certain parts of the input in order to gradually transform the input to the output. Currently, transformer-based models are very popular, particularly GPTs. The G here stands for generative, because they generate large amounts of output tokens by token, unlike, for example, just being a classifier or an embedding or a diffusion model. Then we have P for pre-trained, because they are trained on large corpora of text, For example, GPT-4 has been reportedly trained on 13 trillion tokens of text. That's a lot of text. And T for transformers, the actual architecture use. These architectures are then parameterized and instantiated with numbers, so-called weights. These weights, as said, are created in the pre-training. They are learned, a computationally intensive process. The breakthroughs of the last years are due to the availability of more powerful hardware on the one side to run this pre-training process, but also due to ingenious new machine learning algorithms that make the learning to be far, far more efficient than before. The size of these models are measured in the number of weights. OpenAI's GPT-4, for example, has reportedly about 2 trillion weights. Open weight models, that is models where the weights are freely available for download and that you can run on your own machines, usually have around 1.5 to 70 billion weights. The largest such models go about 500 billion weights. So they're pretty big. So these systems are self-programming based on patterns in the training data, with regards to some goal which is defined in the training. So whereas some people call these models glorified autocomplete, I think that's really unfair, as the models go far beyond that. Jan LeCun, one of the principal researchers in deep learning, calls this differentiable programming, because the programming is encoded as a large set of numbers that then really clever algorithms can efficiently adjust to fit better to the goal function that we want to achieve. And as you know, these models can do some amazing things, because we can use machine learning to learn basically any program that can be learned at all, and then use this magical capability for the hardest tasks we can think of, like, for example, answering questions from humans. And that's an incredible breakthrough and can be used for many, many other things, and I expect also in the coming years that it will be used in many other things. So these new capabilities lead to an end of the AI effect. Even though these models are now available through every phone and on every laptop, we still call it AI. And not only that, not only we still call it AI, but in fact many of the subfields of AI, from reasoning to planning and optimization to my favorite subfield, knowledge representation, they all are starting to lose the association with the term AI. And the term AI is starting to mean only machine learning, and in particular deep learning and large language models. After almost 70 years, the term AI is undergoing a fundamental change, recognizing the importance of these new developments. And whereas I personally think that it's a little bit painful, I also think that it's in many ways justified. This technology might easily be the most important development in the last 25 years, in the century so far. I think it is difficult to overstate the impact this technology will have already in the current state, even if we would stop doing any further research on it. For example, should there be a burst of an AI bubble or something? The new capabilities are so enormous, will take years to propagate through society. The world is recognizing the importance of these developments. The 2024 Nobel Prize in Physics went to Geoff Hinton and John Hopfield for developing the foundations of today's machine learning. It's remarkable. They look like twins, don't they? Thank you, Google. There were many more awards and accolades for the figures in this field. The 2024 Nobel Peace Prize, I keep saying Nobel Peace Prize, no, the 2024 Nobel Prize in Chemistry went to Demis Hassabis, Jack Jumper, and Baker. The 2018 Turing Award went to Hinton, Bengio, and LeCun. And just Wednesday, the 2024 Turing Award was announced to Richard Sutton and Andrew Barto for their contributions to reinforcement learning, a method to be more efficient at learning weights. Congratulations to Professor Sutton and Professor Barto. By the way, when my daughter saw the slide, she asked me, why do I have a slide of mad scientists in my talk? Just saying. The Physics Nobel Prize for Geoff Hinton made him, in fact, a recipient of both the Turing and the Nobel. And I was wondering, was he the first one to receive both? So I asked Google. Yeah, thank you, Google. So that's not what I meant. So does here anyone know the answer, actually? The question is, who got the Turing Award and the Nobel Prize first? No, it wasn't. So when I go to ChatGPT, it answers with Herbert Simon. He is the co-author of the wonderful book, The Science of the Artificial. Unfortunately, ChatGPT answers that Simon is the only person who received the Turing and the Nobel. And it's only 5 months since Hinton got the Nobel. Maybe ChatGPT just hasn't been updated since then. These updates do take a lot of time to go through. And actually, Dan, when I was talking with him earlier, he's sitting in the first row, he was showing me ChatGPT 4.5, and that one did know that Hinton and Simon both knew it. But again, it's 5 months since it happened, and the preview version now knows it. If I ask DeepSeek R1, which was released earlier this year, it in fact believed it was still July 2023, and thus it couldn't have any data about the 2024 Nobel. Can we do better than that? Do we really have to wait half a year before we update our knowledge base like this? So initially, when ChatGPT came out in 2022, 3 years ago, it simply got a question and then used the model, trained on a lot of text, to answer it. And answering could use the answer to the question, and everything had to be intrinsic in the model to answer the question. This led to a lot of mistakes, a lot of people made fun of it, and a lot of work went into improving the reliability of the model. Soon, new architectures were created, such as the Retrieval Augmented Generation model, RAG. You ask the question, ChatGPT then searches the web and reads the relevant documents, and only then answers the question. So, in this case, if ChatGPT would have felt like it, it could have looked it up on the web, I guess, but it didn't do that. So we don't get a notification here that it actually looked up stuff on the web. But we can ask to do it so. So here now we see that it searches the web, it searched for 3 sites, but the answer didn't change, which is really unfortunate, because if we expand the list of the sites that it checked, we can see that it actually read 2 pages which mention explicitly that Hinton is now the second person to win both. And I don't really know what is happening. My guess is that the LLM is so convinced that Simon is the only person with those 2 awards that it's having a hard time updating the knowledge, even though the documents it reads state it explicitly. So here I'm trying to be even more on the nose. I first ask which major awards did Geoffrey Hinton receive? ChatGPT reads up a few pages and lists the Nobel and the Turing. Then I ask, within the same context, if there are any people who received both awards. And again, it answered that Simon is the only person to have done so, even though it just told me that Hinton got both of the prizes. I tried the same thing with DeepSeek. The results show the same reluctance to accept Hinton's Nobel Prize for Physics. Well, I guess if you ask some physicists, they'd feel the same, actually. But it gets worse. If we ask ChatGPT for Croatians, I'm Croatian, so if we ask ChatGPT for Croatians that want a Nobel Prize, it gives us 2 answers and a warning that neither of them actually are Croatian nationality. The warning is very fair. Croatia didn't exist as a country at that time. In fact, whereas Wikipedia currently lists both of them as Croatian and Swiss, Britannica lists them both as Swiss only, so it's fair to give a warning here. So far, so good. But here's the thing. If I ask the same question in Croatian, and trust me, it's the same question. I know most of you probably don't speak Croatian, but I don't get any warning. It just tells me, oh, these 3 here are Croatian Nobel Prize winners. And it gives me 3 names, notice, not 2 as before. And the third one really isn't, it's very difficult to defend him being Croatian. So does the answer to this question really depend on the language I am asking? When I saw this, it reminded me of the great Douglas Adams. Adams is most famous for The Hitchhiker's Guide through the Galaxy, but what it reminded me of was in another one of his books, Dirk Gently's Holistic Detective Agency. The book is about detectives solving crimes, as detectives do, and the book also features a computer program called Reason. The specific thing about Reason is that you first enter the conclusion you want to have, and then you follow with the facts. And Reason then creates a logically plausible sounding way to the foregone conclusion that you gave it. So is ChatGPT here giving you different answers in different languages in order to resonate better with the speakers of the different languages? Let's try another question. Which Croatians have received the Turing Award? Now I'm studying Croatian this time. We see that ChatGPT searched the web. It used the RAG approach we discussed earlier. But I really want to translate ChatGPT's answers. So it says, no Croatian so far has won the Turing Award. The list of all winners can be found on Wikipedia, and among the winners, there are no names that are recognizably Croatian. Honestly, that's just lazy, looking at the names and saying, oh, doesn't look Croatian to me, let's go on. I mean, it sounds very human-kind intelligent, though, so there we are. So what do we expect if we ask the same question in English? Does anyone make a guess? In English, it tells me that there is one person that, although not Croatian, is of Croatian heritage, because even Sutherland's mother, Elsie Krasny-Sutherland, is Croatian, which is kind of cool. I didn't know that. I was really surprised to learn that. But the only problem with that is that even Sutherland's mother is not Elsie, but Anne, and she's Scottish. But other than that, it's pretty cool. I mean, I really learned something about Croatia. So my point here isn't even, that ChatGPT is making stuff up, that it's hallucinating. We know that already. My point is that we're getting different answers if we ask in different languages. Here's an even simpler example. I asked where I was born, where was Denny Vrandečić born? And if I ask in English, it tells me, well, he's born in Stuttgart, Germany. If I ask in Croatian, it says I was born in Split, Croatia. Choose your own truth. Last week, Elena and I were at AAAI in Philadelphia, and I had the pleasure to attend a keynote by the US philosopher David Chalmers. I took a picture during the keynote, and Google decided to add a fun pop-up effect. Well, Chalmers argued that one of the most important research programs we could do today is to work toward a mechanistic interpretation of large language models to understand how we get from weights to propositional attitudes. Basically, we have those numbers. How do we actually figure out what they mean? What does the system really believe? And my point is that Chalmers made a categorical error in his assumptions. As we can see with the last few examples, these systems don't hold any propositions. If they had propositions, their answers across languages would be the same. But they're not. So the answers are happening on a language surface level. All of the, so not on a proposition layer. I agree with Chalmers' goal. It would be really cool to have this kind of mechanistic interpretation. But I think if we presuppose some things like proposition, we might be setting up us for a failure in this project. And if Chalmers is falling for such a categorical error, what chance do we mere mortals have to actually understand those systems? Here's the thing. I don't believe that it's possible that if it doesn't have propositions, that the system has any knowledge, that you can have knowledge without having propositions. I just claimed this right now. We can keep this for later for discussion. But that's what we're here, to talk about knowledge and AI's effect on knowledge. Knowledge is at the core of what Wikipedia aims to achieve, and it's really, really important for us. AI will append many things, and especially knowledge. Let's get to a last form of knowledge that I want to touch on today. Computable knowledge. Computers are supposed to be really good at computing. So the thing that Rodney Brooks said, AI becomes, once we figure out a piece of it, computation. But LLMs fail frequently at tasks where computers should be ridiculously good. And maybe that's why we don't want to call it computing. A paper from the University of Waterloo went through the hassle to check the accuracy of ChatGPT 01 on the task of multiplying numbers with up to 20 digits. 01 was the model that was advertised as being able to do reasoning. So this is a very expensive chart to make, to do a lot of those multiplications with 01. And you can see that it fails frequently when the numbers get bigger. But it doesn't even have to be as complicated as multiplying two numbers. Last summer, there was a news cycle about LLMs being unable to count the number of R's in the word strawberry. So what's going on here? Why can't these very expensive models not count letters, consistently answer my place of birth across languages, or multiply numbers? Now, this is a very different kind of knowledge than the knowledge LLMs. Okay. Can I? Sorry? Ah, I see. What do I need to do? I think JP is coming in a moment to help me. Just click on the slideshow.
Mm-hmm. Oh, I'll let you.
Okay, sure.
I didn't want to go back to the beginning.
Yeah. So, can you see my screen again on remote?
Yes.
Thank you so much. Thanks, JP. So now this is a very different kind of knowledge than the knowledge LLMs store or can access through a RAG. There is no website that contains all the results of all the multiplications. There is no list of how often each letter appears in every word. Such websites would be ridiculous, right? Maybe April Fool's jokes and that's it. So for this, we need a different solution. In addition to RAG, the retrieval augmented generation, we talked about earlier, we now can also add something called code generation with execution. So the LLM is really quite good at writing code. The idea is that for certain types of questions that can be answered by computable answers, the LLM can generate the code and then will run the code and compute the answer and return the answer. To give you one example, let's figure out on which day of the week King's College was founded. So my first step was to ask Google when King's College was founded. And let's ignore this thing up there. So 1829. Thanks, Google. And in fact, it's 14th of August, 1829. Now I can ask ChatGPT what day of the week that was. And it answers Friday. So you see this little icon there, it tells us that it was using code generation and execution. If you click on it, it shows us the code that it wrote to get the answer. Now, given the code it wrote, I'm curious what it does if we move out of Python's date range. So Python can deal with the years from year 1 AD until 9,999 AD. It can't deal without of it. So for example, let's try the date that Julius Caesar was assassinated, 15th March 44 BC. And if I ask Google, that's maybe a Tuesday. I mean, it's looking for 17 March 44. I have no idea what it's doing. Never mind Google. Let's try ChatGPT. So here's the answer. First, ChatGPT tells us that it couldn't pass the date. which is a bit of a weird answer. And if you look at the code, you see actually that, well, just the code failed. It wasn't writing good enough code to deal with 44 BC. So then it tells us, oh, you know, in reality, the Julian calendar was in use. That's why I don't know the date. It's not that I actually said that I wanted to use the Gregorian calendar, but okay. Also, it's absolutely a cop-out. If I ask about 15 March 44 AD, the Julian calendar was in use just as well as 44 BC, it will just give me the answer without making any trouble. So it just knows, oh, something's going wrong. It's probably the calendar, yeah, trust me. It's just looking for an excuse. And finally, it tells me that using historical references, whatever that means, it was a Friday. Does anyone here believe the answer? Well, I don't. So I gave you numerous examples of where LLMs, and also Google search, by the way, have gone wrong. Errors, big and small, but honestly, I don't think that any of these examples matter much. The world is moving on, and LLMs have become a popular part of the information ecosystem. The smooth-talking answers of LLMs are just too convincing. We associate a competent use of language with high intelligence, and we associate high intelligence with trustworthiness. Also, to make it again very clear, as I said earlier, I think LLMs are incredibly powerful, amazing things, which can be useful in so many ways if used right. So what we really have to do is we have to help them to become better. We have to increase the accuracy of LLMs. Can we do that? I think the answer is a clear yes. And here's an intuition about why I believe that. In 2022, the same year that ChatGPT came out, Stable Diffusion was released. Stable Diffusion is a generative model to create images. And here are some of examples of more or less famous peoples explaining knowledge graphs. Maybe you can recognize one or the other person. Stable Diffusion achieves that goal with 890 million parameters. That's a measure of how big the model is, as I said earlier. Now, you may think 890 million parameters is a big number, right? But compared, for example, to ChatGPT-4, about 3 generations ago now, which has 1.7 trillion parameters, billion, not trillion, it's tiny. ChatGPT-4 is about 2,000 times larger than Stable Diffusion, more than 3 orders of magnitude. Is this because natural language is so much more difficult than vision? Like, can we represent the face of Helen Mirren in so many fewer ways than talking about all these things? We know intuitively that this isn't the case. It's because these large language models also include a mirage of all the world's knowledge. These trillions of parameters are storing my 2 different places of birth in 2 different languages. That takes parameters, it takes weights. If we could kick out that knowledge, these models could be much smaller, much cheaper to run, and with extension to the architecture, also much more accurate. We could use an architecture where we not only use the web for retrieval augmented generation, but use a structured knowledge base for the kind of global questions like who won the Turing and the Nobel at the same time, and use a library of functions for questions that have computable answers instead of generating the function every time again. For both of these, Wikimedia offers projects, Wikidata and Wikifunctions. Let me introduce both. Wikidata is an open knowledge graph that anyone can edit. It was launched in 2012, 13 years ago, and provides structured linked data and persistent identifiers for many topics of interest. Wikidata is entirely multilingual. You can use it in any language you want. You can contribute to it in any language you want, but it's always the same graph underneath. And it is used extensively by Wikipedia and many, many other projects, companies, developers, such as Apple, Microsoft, Google, the BBC, and many others. also in particular by research teams all around the world. Google Scholar lists more than 39,000 research papers citing or using Wikidata. So in Wikidata, we have items. Those stand for topics of interest, and it started with whatever Wikipedia articles are about. So we have an item for the Turing Award. Did you actually know that this cup is the Turing Award? I had no idea until like yesterday. So we can have an item for the Turing Award. We can have items for Turing Award winners. Let's just put some of them here. And for other researchers. And now we can connect the items with a property, a labeled arrow that is, has a label. So this one is labeled with received reward. So we have here, those people here all received the ACM Turing Award. At any time, we can add more items, for example, an item for the Nobel Prize, and then we can add more connections. We can add items for new types of things, for example, an item for Croatia, and we can connect new properties, for example, one for nationality, and we could have done much more. I skipped it. The slide was getting already very busy. In reality, Wikidata is far, far more busier than what you see, obviously. In Wikidata, we currently have more than 116 million such items, connected with more than 1.6 billion statements. It's all available in 495 languages, which I find pretty impressive. I mean, how many websites do you know that have 500 languages available? And Wikidata is, like all of Wikimedia's projects, driven by volunteers. And we have more than 25,000 monthly contributors to Wikidata. And overall, more than 500,000 people contributed to Wikidata so far, a number I personally find absolutely astonished. When we started Wikidata, I would not have believed that there are that many people in the world interested in contributing to structured data. Wikidata has so far seen more than 2 billion edits, making it by far the most edited wiki in the world, easily beating the English Wikipedia, even though this is double as old. It also includes my favorite edit. Here, it's about children's animation character Spike. And what we see here is it was changed from being an instance of dragon to an instance of a fictional dragon instead. I'm glad this was clarified. All of its data is available in the public domain, can be just grabbed and used for all kinds of things. And because, as the famous Croatian New Zealandian Turing Award winner Ivan Sutherland has said, knowledge is a rare thing. You gain it by giving it away. So can I ask Wikidata about the Turing Nobel winners? And it absolutely can. Well, I can, and people who know the Sparkle query language can, and they know the Wikidata data model, right? We can write a query like this. Sparkle is a standardized query language for knowledge graphs, but here's the nice thing. Knowledge is gained by giving it away. That's what just Sutherland said, right? The Wikidata community has written a lot of documentation on how to write Sparkle queries, possibly the most comprehensive resource on Sparkle in the world, with tons of examples. And they publish it all on the web. All these language models we have been talking about have been trained on the web, including all this documentation about Sparkle. So they have seen all these examples, all this documentation, and so on. And I can just go to ChatGPT and ask it to write the query for me. And it does a pretty decent job, out of the box, without any fine-tuning or further instructions. It knows many identifiers of Wikidata items, of Wikidata properties, right out of the box. I found this pretty amazing already, but it gets even better. Monica Lamb at Stanford and her team developed Spinach, an architecture that does things like looking up the identifiers first, making sure they are correct, trying to run the query, checking for plausibility, and is fine-tuned on the Sparkle query corpus and more. So I can ask Spinach for the query, and it's not only half decent as ChatGPT is out of the box, but it gives me the correct query right out of the box. I can just run this, and then I get the answer that it was Hinton and Simon who got both awards at the time. And unlike ChatGPT, which takes like half a year to update, this update happened 7 minutes after the announcement, 8th of October 2024. So this also shows that it would be quite easy to integrate a chatbot like ChatGPT with a knowledge base such as Wikidata. Let's get to the last part of the puzzle, Wikifunctions. Wikifunctions is Wikimedia's first new project since 2012 when Wikidata started, and it's entirely brand new. It just started last year. It has been mostly financed by donations from Google, the Wikimedia Endowment, and the Rockefeller Foundation. And by the way, we are actively looking for more funding. If you know anyone, I'd really like to speak with them. The project is multilingual, just like Wikidata is, but not only in terms of natural languages, but also in terms of programming languages. I'll come to that in a second. It allows you to implement functions in different programming languages and in other different ways. Wikifunctions provides a library of functions that you can use in many different circumstances. But what is a function? What does it mean? So functions answer questions, as we have seen. It's kind of computable questions. And if you have something that answers questions, that's knowledge. We have seen that before. They are not the kind of knowledge you would find in a knowledge base, such as Wikidata. It's not declarative knowledge. It's computable knowledge or functional knowledge. It allows you to compute the answer to a question. Let's look at a few very simple examples. Here's a function that does the Caesar cipher, shifting each letter by a given number in the English alphabet. So King's College London, shifted by 13 letters, becomes Xwatpupturt Yubabke. Sounds a little bit like Hutties from Star Wars to me. Here's one calculating Celsius to Fahrenheit. We have a function that checks whether a given year is a leap year or not. So here we see, for example, 1900 was not a leap year. Let's take a closer look at this in order to see how a Wikifunction function actually looks like. So every Wikifunction function comes with tests associated with the function. In this case of the leap year function, we have 10 tests. We also see 4 columns for the 4 implementations that we have, to that in a second. In this case, all the implementations pass the test, and also all the tests are connected, which means they are actually meant to run for these functions. And this is like the ideal case. So we see a lot of examples, and we see what should be the answer and how they pass. For this function, we have 4 implementations. Implementations can be in a programming language. One of the implementations here is in JavaScript, one is in Python, or they can be a composition, which means that they are taking existing functions and combining them together. So the implementations aren't particularly surprising. This one here is the Python implementation. We follow the usual rules for leap years and Gregorian calendars. If it's divisible by 4, it's a leap year, unless it's divisible by 100, in which case it's not a leap year, unless it's divisible by 400, in which case it is a leap year. So just here encoded. The JavaScript implementation looks quite different. It's also interesting to see why it is so different. And this is because someone stumbled upon this discussion on Stack Overflow about what is the most efficient leap year test, what needs less tests. And the Wikifunctions community copied them and learned from that. If you're using the Wikifunction functions, you don't have to worry about getting that right anymore. You just get the best implementation out there. Now, if you or nor any AI trying to come up with this, you can just use what we have in Wikifunctions. Also, I don't have to worry or prove that the JavaScript and Python implementation are actually the same, because we have the test suite, which will cover those things and look at it if it's the same. And we can always run the different implementations individually and see if they come to the same result. Now we also have 2 compositions, as we have said. One of them is, which is a pretty straightforward translation of the rules. We check if it's divisible by 400, then by 100, and then by 4, and give an appropriate answer. The other one is a little bit sneaky. I like this composition. So what it does here, it says if the year ends with the same day of the week as the second day of the year, then it was a leap year. You can convince yourself about it by looking at a calendar for 2024 and 2025 and comparing that. But again, you don't really have to. We have the tests to check that. So if it works, it's probably fine. And I want to use this example also to show one aspect of compositions. Since Wikifunctions is multilingual, just like Wikidata, that means that each function is actually a numeric ID, a set ID, with labels in the respective languages. So I can see this composition here in English, but I can just switch the language, for example, to German, and see the whole composition in German. This allows contributors who don't speak English to contribute tests, to contribute implementations, to read the implementations and understand them. We know there's enough research that learning programming language is impeded by the necessity to first learn some basic English, because basically every programming language is based on English. So if we don't have to learn English anymore in order to understand programs, in order to contribute implementations, we are widening to a much larger audience the ability to contribute implementations. Here's a function. Here's a function from the chemistry domain, telling us, giving a number of electrons, what the subshell configuration is. Oh, wrong direction. So here, sorry. I have a different destination here. And then we can also see the things that stumped us earlier. We have a function to multiply two numbers. And they can be big numbers, and we actually get the right answer. And here's a function that counts how often the letter R appears in the word strawberry. Also gets the right answer, 3. We're better than those billion-dollar LLMs. And here's the function that figures out a day of the week, also for dates outside of Python range, such as the 15th March, 45 BC, which was the first day, by the way. We currently have more than 2,200 functions in Wikidata, in Wikifunctions. And we have names and descriptions in more than 100 natural languages. So far, we had contributors from more than 50 countries contributing to Wikifunctions. And the page views of Wikifunctions are growing fast. I mean, nowhere near Wikipedia, obviously, yet. And the project is still at a very early stage, but the growth trajectory looks promising. Some of the numbers from last summer are unfortunately inflated. That happened when some of the AI startups started to scrape Wikifunctions very heavily. We had to block them because they were taking the site down. Let's get back to this architecture. With this architecture, where the LLM doesn't hold the knowledge, we might have a small language model instead, which mediates the questions and the sources of knowledge. We can use basically the same architecture, the same language model, not only to mediate with the web, with Wikidata or Wikifunctions, and use functions that are vetted and tested instead of, writing them on the fly and hoping that they're right. And this is why building Wikifunctions, and it's an investment which will also pay back into this new world of LLMs. Wikifunctions allows anyone to access functions and to answer questions. Today, programmers have easy access to all kinds of functions, but many other people do not. With Wikifunctions, we want to expand the usage and also the creation of functions to enable many more questions to be answers. We aim to allow people, even without knowing English, to use functions, to create new functions, to implement them. I think there is a large pool of potential contributors. We hope that Wikifunctions will lead to the creation of a comprehensive library of natural language generation functions for hundreds of natural languages, which will be a major stepping stone towards something we call abstract Wikipedia, where the content of Wikipedia would actually propagate from one language to another. Here are some examples in this direction. This function, giving the infinitive of an Igbo word, Igbo is a language spoken by more than 30 million speakers in West Africa, generates the regular imperative form. This was created and tested by Igbo speakers, and they were able to deploy this function to the world on the web and make it accessible to everyone else. It was beautiful to see the shine in the eyes of the Igbo speakers when we talk about them after they're showing off the function, showing off the work they did. Something that would have been much, much more difficult without Wikifunctions. Here's a function working on English with an irregular form, getting the plural of goose, picking up the correct form for Wikidata, which is this kind of lexicographic knowledge recorded. Here, for example, we have a function that creates the English possessive. And this one is to create an indefinitive noun phrase. What we see here is that we pick up, for example, a noun from Wikidata, an adjective also from Wikidata, and say, okay, we create an indefinite noun phrase in English, for example, and it creates me a black cat. Now I can switch the language, for example, to French, and it creates me un chat noir, or to Spanish, un gato negro. I don't have to speak those languages. It will just generate the sentence by choosing the language, picking up it from Wikidata. And I could do the whole thing also through the French interface, saying, okay, in the French interface, I'm using the same item and the same adjective. They're also translated, and saying, do it in English, in anglais, and I get a black cat again. These new abilities, these natural generation functions, are necessary for the abstract Wikipedia project. We are working on a frame-based representation of a much larger portion of the knowledge in Wikipedia, in order to turn it into text into many hundreds of languages, so that the change through a contributor in any one language will automatically propagate to all the other languages of Wikipedia. This allows us to start building articles about topics such as Gladstone in many languages that currently don't have an article in their language. And everyone can edit the article in their language, working on a common knowledge base, closing the many knowledge gaps in Wikipedia and getting us one step closer to a world where everyone can share in the sum of all knowledge. Thank you for your attention.
All right, so thank you, Denny, for the presentation. I have written down 3 questions, but I want to give the room the chance to ask. Who wants to go first? Yes, please.
Thank you. Thanks, Denny, for the talk, first of all. And I have a question related to when you were saying, without all of these hard-coded knowledge, we could have models with much fewer weights. Once we introduce a knowledge base as a backend to our models, how do you think we could start using local models, for instance, open source models, instead of relying to services?
The same way, basically, if the knowledge base is also available in the open, like Wikidata is, we could just use an open knowledge base like this, either having it downloaded on your own machine or just using it over the web and using the same knowledge. So I don't see a big of an issue here. Obviously, if you are Google or Microsoft and have, even bigger knowledge graphs inside, you will be able to answer more questions with that. Also, you can create, actually, your own knowledge graphs. And, I mean, this is something that's happening right now within the Wikidata community, that they have more and more other Wikibase instances for particular areas where they're creating their own knowledge. You can just point to those and say, well, get this knowledge from that particular knowledge graph, for example. So I would hope that both personal knowledge graph as well as community-driven knowledge graphs for specific domains will become more frequent and will be used by these systems in order to answer these kind of questions.
All right, yes.
Hi, thank you so much for the talk. I was curious, with ChatGPT, giving you different answers in different languages, what is your biggest ethical concern with these, because I'm studying AI at a different university, but the ethics is what I'm really interested in, because I'm not an engineer. So if you could just talk to that.
What is my biggest concern about getting different answers, different
Ethical
questions?
concerns
Ethical
around
concern.
that.
I don't even know how to start. No, I mean, I don't think that having different answers in different languages is a good thing. And it's just helps to deepen divisions between the language communities, which I don't think that languages are the right places to make those divisions in the first place. There might be valid reasons to give different answers for different questions. For example, the audience might be different, like kids or whatever, who might require a different answer for specific questions than adults and so on. I don't think that languages is anywhere near being the right delimiter. And I also don't think that this is happening intentionally at all. So given that there's no design in this, it's not a product decision that this is happening. This is just the way it is. I think this is not unethical in the sense of someone is intentionally being evil, but it can be used for, its usage can lead to further bias and problems.
Thanks, Danny, for the great talk. So I have a question about the connection between Wikidata and Wikifunctions. So you've shown how you can connect the two for doing this sort of linguistic and lexeme computations. Do you think this is also a chance to connect, so to do semantic computations about the items themselves rather than just their lexemes?
Yes, absolutely. We currently don't have all the data types lined up for that, but it's something that we expect that will be available during this year. That you can ask, for example, question, did these two species live at the same time? And then you can look up, oh, okay, they got extinct at that date and so on. So basically, in Wikifunctions, you will have access to all of Wikidata's knowledge in order to answer your questions, which can make it a very powerful function library.
Thank you, Danny. I really wish my students were here, but they are not. Anyway.
It's recorded.
Great. We'll make sure that they watch it. One question. How do you see, or what do you believe we can learn from how LLMs saw themselves as not just another computation? In terms of like weak function, you're offering new functions and you're offering them in different languages. You do, in your model, accept that LLMs are here and they need to be. And of course, at the moment, they are a success. And what is it that we can learn from them, not just being faded by this, as you said, the guy from Roomba, I believe, that he said that everything became just a computation. What can we learn from how they've done it?
I'm not sure we can learn much from that, because I don't think it was an intentional process at any point. ChatGPT was an accidental success, also for the people who launched ChatGPT. They didn't expect this to be such a big thing. Because for them, it was like, well, those models were doing this for half a year. It's like, what's the deal? But suddenly, it was a big thing, and it was on everyone's browser, right? How the terms are being used, I don't think we have much control over these things. So I'm not sure we can learn much from that, because I think it's mostly accident how those things happened. But I'm sure that at some point historians will actually write these things down and get a better picture, and then we will figure out what we can learn from that.
The ability to interact with the system in tech using natural language rather than Spark.
Yes, I mean, that's definitely something, and that's why I think they are such an important part of the infrastructure of the future. Talking with the computer, I mean, seriously, we've seen it in Star Trek, we've seen it in so many movies. This is so obvious something needed, right? There's no way that we can get back from that.
All right, so I'm going to ask...
I have a question, if it's okay for me to ask.
Is this you, Aditi? Yeah?
So is there any effort to use LLMs in conjunction with Wiktionary for the revival of endangered languages?
That's a really good question that doesn't have a very short answer, but feel free to reach out to me afterwards. In general, we want to connect Wiktionary and Wikidata much stronger over the next year or two or three. And hopefully those things will grow together and therefore will become also accessible much easier to LLMs and other users of the data.
Yeah, thanks, Danny, for a great talk. I have two questions about Wikifunctions. So first is that we all know that Wikidata is collaborative built like knowledge base, and also it also can be contributed by bots. So would you envision that, like envision there's going to be a bot contribution to those wiki functions? Like if we read user manuals of all Python packages, then we can create some sort of like automatically contributed wiki functions.
I expect that this might happen at some point. It will go through the community process like for all the other projects. I expect it will be much less prominent than on Wikidata, just because, I mean, the kind of data is different. I mean, but I do expect that some tasks are really well bottable, and we'll have some bots doing that. I mean, Wikipedia is difficult to bot, and nevertheless, there are tons of bots working on Wikipedia. This kind of things will also happen on Wikifunctions, I'm sure. Whether we will upload whole libraries of functions, I don't know. This is something that the community has to decide. I don't have an opinion on that.
All right, so I'm going to ask one of my questions. Say, Gladstone is a black cat. What if a certain culture or Wikipedia version disagrees with that, what do we do with such contested facts?
Yes.
In abstract Wikipedia?
Yes. The goal of abstract Wikipedia is to close the gaps in current Wikipedias. If there's a culture who has a very strong opinion on Gladstone, they are and will remain free to just write an article by hand, basically shadowing the terrible word in this case, shadowing the Gladstone
Mirroring.
article, closing, obscuring the abstract Wikipedia article. So, and this also actually gives the communities the freedom to choose the articles that they really care about. They don't have to write an article on every element anymore, on every country and so on, every city in Japan if they don't care. They can write on the stuff that they care and then just take the background knowledge from abstract Wikipedia and fill the gaps in. So they will always have the last say about what is really displayed on the Wikipedias.
Okay, thank you. So another question online from John Davis. How can we use AI to improve the neutrality, brackets, to remove bias in Wikipedia articles?
That's a great question. Thanks, John. I think that's a whole research project.
Okay.
I don't have a ready answer for that.
All right. And there's another question, which is again a bit more general. Has there been a lot of study on how ChatGPT answers political questions in different languages or even dialects of the same language? Do specific patterns in US English, for instance, trigger more Democrat or Republican-leaning answers? So I think the answer is yes. There's been studies for that, but I don't know if you wanted to add anything to that.
I don't have. Do you have anything to add on that? Yeah? No, since you're doing ethics.
Do you mind repeating the question?
So the question was whether there have been studies that ChatGPT gives you different answers if, depending on whether they think you're more left-leaning or right-leaning.
Oh, I definitely think that. I think in the States for sure. Like if I Google something in New York and my grandmother Googles it in Florida, we get completely different answers. So.
Okay, so I'm going to give this gentleman a chance to ask a question. Then I'm going to ask my final question.
Thank you. As AI-generated content becomes more prevalent, what role can informatics and Wikimedia play preventing disinformation, in the election time or some peace process? It is very important.
Yeah, I wish I had an easy answer for that one. I don't. We have a whole team at the foundation. I know that there are a lot of other organizations that have teams for doing this kind of work. I don't think it's getting easier to solve these things. And also this leads me back to John's question. I mean, I would hope that with LLMs, we actually have methods available to check on a larger scale for biases and maybe find the places where they are. But I really don't know if there is any research already doing this kind of thing. But it feels like LLMs should give us also the opportunity to check a lot of the data more efficiently than they did previously. And the same thing applies here. Maybe we can train an LLM to look for markers of biases, of misinformation and so on. I think it's not easy. There is no algorithm for truth, as Tom Scott says. But yeah. Something like this might work.
And they're using the same sort of foundation
yeah.
models. There's also a question, there's a question of whether you want to fix that on a technical side and have foundational models, or you want to fix that on the user interaction side, where there's also lots of very interesting work coming out of human AI interaction that says that the LLM should challenge you. So when you ask for something, it should actually say, well, maybe you want to look at this and this, and actually encourage you to engage with the content in a different way.
But in major to put, sure, there are now easier ways to do disinformation, to do biases and so on, but we also have much more powerful tools available to actually counter those things.
Okay, Dan has one last question.
This is not the question, but there was a paper out of Stanford on, I think, ChatGPT treating African-American names differently in a bad way. That might be worth binging or whatever. You started to say you can't have knowledge without propositions, and then moved swiftly on, either because you knew it was unsustainable or it was a distraction from your true mission. LLMs are full of book learning, whether they contain propositions. We could sit on one side for now. Would you say chimpanzees, corvid birds, octopus, in some sense have knowledge, maybe knowledge in the knowing how sense rather than knowing that sense?
I would actually say that chimpanzees and some other animals hold propositions, certainly, even without holding language.
I thought you might say that, but the other bit, would you admit that there's useful forms of knowledge that ground our lives that are not propositional as animals?
Okay, yes. Okay, yeah, I grant that kind of knowledge. I was actually thinking about the kind of knowledge that is propositional, obviously, can be held without propositions. And this makes it a tautology. You're right, I was incareful on that thing. But I also think that language models don't hold this kind of knowledge in any
Absolutely,
way.
I wasn't trying to trick or trap or whatever you. It's more, does thinking about animals help us get a sense for what AI dominated by language models might be missing, other than wiring up our lovely semantic web data sets, which is my favorite thing too.
I started having like about 20 slides about the question of knowledge and so on, and I just kicked them all out yesterday evening, fortunately.
A shame. So we're this is somewhat related, but not exactly the same. So you talked about propositional attitudes, right? So propositional attitudes in that talk that Denny cited from last week from Philadelphia are essentially triples. So Gladstone is a black cat is a propositional attitude, and then the question that you want is a beliefs, exactly. So then on top of that, you add your belief, hope, imagination, whatever. So a verb, an attitude verb that would describe. So my question to you is, could it be that the reason why you're getting all these different answers across languages and whatnot is because large language models have been trained to optimize something else? Keep the user happy. I don't know, keep the conversation flowing. Some other engagement attribute than actual accuracy and consistency across languages.
It could be, and this is why I was mentioning Douglas Adams' reason thing, like trying to come with a specific conclusion, not trying to give you a nice explanation for that. The answer to the Nobel Prize indicated that, because the Nobel Prize sounded more Croatian in Croatian, but the answer for the Turing Award was like actually more Croatian in the English side. So this gives me that it's probably also, it's not always repeatable. It's probably a question of temperature, so it's like whatever the moon phase right now is or whatever. It's basically, I don't think it was, it's designed really, it just happened to be the answers there. Also, to make it very clear, I wasn't looking for any of those errors that I was showing today. It just happened and I just collected them. It's not that I went ahead and searched for, oh look, where can I find a mistake in the system? I wish it was the case, those systems would be much better, but that's where we are.
Yeah, I read a very good tweet today, well, not tweet because I'm not on Twitter anymore. I'm on Blue Sky. So the posts read something along the lines that every time I ask ChatGPT on a topic I know very little about, it seems to give me lots of very useful knowledge. Every time I ask it to give me on a topic that I know a lot, it gives me around 40% of accurate knowledge. So that was not to be a scientific experiment, but it sort of resonates with the examples that you had. And with that, thank you very much, Denny, and thank you everyone for the questions and for being here today. We're going to move on now to where? To Bush House 5th floor. Bush House 5th floor, so follow the crowd. Some of us live in Bush House. Goodbye to our colleagues who are online. Maybe we will see each other in Bush House as well. Thanks again, and thank you, Stefanos, for the organization.
Thank you for having me.